Hey guys, Peter Taoussanis here. So trying something new with the video format. We'll see how this goes. Today I want to do an intro for a very small library which I'm releasing for Clojure and ClojureScript. It is called Truss, and it is an assertions library. I will show you what I mean by that. So let's start with a bit of a contrived, motivating example. You have this function in your codebase. It takes a sequence of names, capitalizes each of them, joins them together as a string, right? You have tested it at the REPL, and it's working well. Anyway, it found its way into production. So one day you see this error in your production logs, and the question is, what happened, right? What did we miss? What do we need to fix? So take a minute, actually look at the error message and see if you can figure out what happened. If you have spent some time with Clojure, especially the string API, you might figure this one out right away or pretty quickly. Otherwise, it could take you a while. In this case, it looks like we've probably passed in a nil name by accident, and that's tripping up the capitalize function. If you have used the Clojure string API, you've probably run into stuff like this, and you know that the string args need to be non-nil, or they will throw an NPE. The point of this example is, we made an easy mistake, a pretty common mistake. We didn't catch it during development or think to test for it, and we eventually ended up with a stack trace. Now, it turns out in this case that the stack trace helped us debug the problem with a little effort, no big deal. The bad news is that this is a superficial example, and it's pretty much a best case scenario. It was a one-line function without any dependencies, one argument in, not a whole lot of ways it could be throwing an NPE. And even in this simple case, our error message may have already been a little on the tough side to digest. So imagine you have a 20,000 line complex code base that suddenly breaks one night in production with an NPE that doesn't make a whole lot of sense. A real possibility exists that you are going to be in for a rough night of debugging. By the way, I will point out, if your unit tests didn't catch the issue, it probably means that no one has ever thought of the particular set of circumstances that's caused the problem, which means you might not even be logging the information that you're going to need for debugging. So if the stack trace was unhelpful, the debug info you need might simply not be available anywhere. There is good news, and that is Clojure is a beautifully designed language with some really smart practical design choices and trade-offs. Things like its functional leanings, immutability, expressiveness, conceptual simplicity, how concise it tends to be. These mean that in practice, production Clojure code is often clear, easy to understand, and really short. You add REPL-based development, and I think it's a pretty common experience to find that Clojure production code is pretty competitively reliable and workable, let's say. And that tends to be true even for large code bases. But software engineering is hard, and as our projects get bigger and more complex, they become more challenging to write and maintain. That is sort of an intrinsic property of the software, and it would be true regardless of the tools that we're using. In the specific context of Clojure, I have been using the language for a bunch of years now and have a lot of time in with it. That is, time writing small applications and some really big applications. And it has been my experience to observe certain common incidental challenges come up disproportionately often or cause a disproportionate amount of headache. Specifically, undocumented type assumptions changing. So we wrote this function assuming that this arg would be non-nil. That assumption is baked into the implementation. At some point, we forgot that that assumption is baked in. We make a change, we break the code, and we have to spend time trying to figure out what we broke. Second, documented type assumptions going stale. So same function, someone has thought to document the non-nil type assumption, added it to the doc string or an inline comment. At some point, someone edits the function and forgets to update the docs. So we now have an inconsistency. Something ends up breaking, and we need to spend time figuring out what broke. Ultimately, both of these boil down to issues with Clojure's error messages. When we inevitably break something, the error message we get is rarely as helpful as it could be. And it can be pretty useless. Like basically something of the form, there is a problem. Now, Clojure's error messages have been getting better, but because of the way that it's hosted, I don't think it's super likely that they are ever going to be fantastic. And anything less than fantastic means that you are spending time debugging incidental problems. That is time that you are taking away from more valuable stuff like actually moving your software project forward, right? So there is a bright side, in my experience. If we can improve the error message story in a few necessary places, we can eliminate a surprisingly large proportion of all our incidental problems. In other words, Clojure code bases, large Clojure code bases, don't have many incidental problems. It's this and not much else, which is wonderful. And especially wonderful if we can fix this. So that is what Truss is about. It is a small practical solution that I found personally helpful at targeting these specific issues and improving error messages, right? So a very brief comparison to some other options. First off, I will point out I am not addressing the notion of just using a language with static typing. If you are using Clojure, you have presumably evaluated its particular set of trade-offs, and you have already concluded that it is a productive fit for your particular team and objectives. So maybe you enjoy its dynamic typing, as I tend to do, or you have otherwise accepted that as part of its bigger package, right? Either way, we are working with what we have to get stuff done. So, options within Clojure. Most common one, probably documentation. Doc strings and inline comments. So document special types, conditions, that sort of thing. And that works well until it doesn't. Code tends to be buggy in inverse proportion to how often it runs, right? And a comment is code that literally never runs. It can go stale, and it tends to go stale in practice. So then you've got a case of the two disagreeing, which is often worse than if there just weren't documentation. For this reason, I tend to try and minimize comments in general. If you can write the code in a way that's clear enough that it doesn't need comments, that is often ideal. I think especially for these kinds of comments, so stuff like, this argument needs to be non-nil. I promise you, stuff like that, comments like that are going to go stale. All right, unit tests. These are popular in Clojure. They are often recommended, and they are often very useful. I wouldn't hesitate to pull out unit tests in the right case. What I might suggest is that in the case of the very specific kinds of errors we're talking about here, unit tests can be suboptimal in two ways. Number one, they can involve an unreasonable amount of overhead to write and maintain for a type check. You've got to set this whole thing up to properly exercise maybe some internal type assumption. It's doable, but it can be time-consuming, which means that either you are spending time on this or people are just ignoring it. Either way, suboptimal. Second way, unit tests are maybe not an ideal tool for what I'm talking about here. Unit tests tend to be separate from your code. So in Clojure, usually in a separate namespace or at least in a separate code block. And if we are talking about a unit test that exercises important conditions of our function, then to fully grok our function, we need to also look at the unit test. So we've distributed important information about our function's internal logic in two places. And for some kinds of tests, that kind of separation can be desirable, right? I would argue, though, that for the specific kinds of errors that we are talking about here, what we ideally want is an assertion in the code. So, obvious question, what about Clojure's baked-in assertions or pre-post conditions, right? Let me show you an example. So, let us say that somewhere on our code base we have a function, something like this, let's say. Okay, so it's a square function, takes an input, multiplies it by itself. And if we call this with 5, we are going to get the expected output, which is 25. And if we call this with something like the string of 5, we are going to get a class cast exception. Okay? So let us say hypothetically that we want to try and improve this error message. This is another super contrived example. I really wouldn't suggest actually using assertions in a case like this, but we're just kind of exploring what options Clojure gives us out the box. So one of those options is we can write an assertion over here. So we say, at this point, assert that n is a number, right? If we want to be a little bit more specific, we could say, okay, maybe n is an integer. Or if we want to express it differently, we could do this as a precondition. Say maybe n is an integer over there, which means if we run it over here, square 5, we get the same output 25. And if we run it here, our error message has changed, and it now gives us an assertion failure. Okay? So this error message is in some ways a step up and in some ways a step down. It is telling us that the input to the square function did not satisfy the integer predicate. But it is not telling us what the input to the square function actually was. We don't know what its type was. We don't know what its value was. Now, in this case, we do know because we're entering this at the REPL, so the input was 5. But if you see this error message one day in your production logs and you're not logging the input to the square function because you weren't expecting it to be a problem, then this does not give you a whole lot of information to go on. You would want to know, was the input a nil? Was the input a string? Was the input a collection? Because that's going to help you debug and figure out, well, where is this getting into the square function, right? What consumer of this function is accidentally allowing in the wrong kind of information? So my feeling, again, these can be helpful. They are suboptimal. They still waste too much time. What about core.typed, etc.? You have got a bunch of these awesome library options available today, including, of course, gradual typing with core.typed. And these are absolutely, definitely worth checking out. I haven't used Schema, so I can't comment deeply there. I do use core.typed from time to time. I sometimes use it with Truss. I think the point here is that you try to find something that fits your team and your objectives in a way that you find productive. In my particular case, I had some specific objectives in mind. So specifically, I wanted something really small that is immediately easy to understand so that even if a beginner is reading some code and she has never seen Truss before, she will grok what is going on and feel comfortable to make changes. The Truss API is basically one macro. It's a predicate argument macro, and that's it. The code base is like 200 lines long or something, and it's mostly documentation. Okay, flexibility, I mean arbitrary predicates. I don't want to have to fight a type system to define some kind of weird one-off transducer. I want to describe the aspect of the system that I care about checking and get back to work. Third objective was an important one for me. I want to be able to use this in projects, including code for clients and in library code. And I want to be able to reinforce code exactly where and when it makes sense to do that. So if you have spent some time with Clojure, you will be familiar with how rarely you usually end up reaching for the STM. I have got code bases with 50 lines of code, 50,000 lines of code and like 2 uses of the STM. The thing is, the STM is awesome, and sometimes you will really want the STM. But because of so many other great design decisions behind Clojure, you come to notice that most good Clojure code rarely needs to lean on the STM at all. It just doesn't come up. And I would argue the same situation with the kinds of assertions I'm talking about here. A majority of your Clojure code is going to be obvious, easy to understand, easy to debug, because Clojure. And a lot of it anyway is not going to be important. So does it make sense to annotate obvious code that rarely runs and isn't important when it does run? I would consider that sort of an anti-pattern. As a sample of one, I've been using Truss for a bunch of years. I just grepped before doing this over about 100,000 lines of code that I have handy, and I picked up maybe 100 Truss assertions. So that's like one assertion to 1,000 lines of code. What I can tell you is that those assertions have saved me enormous, like, make or break the project amounts of time, because they have been exactly where I needed them to be. So the goal here is to be able to add one assertion and get something potentially very useful out of it. Assert precisely the property or properties that are interesting, nothing else. No need to annotate 10 lines over there to get a benefit over here, no need to force requirements on library consumers, and no need for a buy-in cost. So if you want to try Truss in a project of yours or a library, you pull in the Truss dependency and you add one assertion anywhere you like. You're done. Okay, so I have been talking about this all mostly in the abstract since there's not all that much to show. Again, the Truss API is intentionally small and you use the bits you like. So the main thing I would like to do now is give you some ideas of Truss syntax. The examples are inherently contrived. You are rarely going to want an assertion on a one-line function. You will want it in the hairy parts of complex code. So please take these as examples of syntax and not use case exactly, if that makes sense. So let us quickly, I guess for starting point, we'll recreate that silly square function. And then, okay, so we can call 5 over here and get back 25. Or we can call it with the string 5 and we get a class cast exception. Okay, so let's say hypothetically we want to try and prove this error message somehow. Again, bad example of something that you would want to actually assert on, but let's say we're doing this for whatever reason. And our Clojure assertion would look something like this, which gives us this error message. So we would like to improve this error message, okay? And we will improve it by bringing in the Truss API, or Truss dependency anyway. Okay, so we've pulled in downInsert.truss, and we are referring the Truss macros. The have bang, have question mark are not super important. There are slight variations for convenience, but the main one is have, right? So we will pull that in, and we are going to transform this Clojure macro to the equivalent Truss macro. Okay, so this was of the form assert, and then a something that's going to evaluate to true or false, right? In the Truss case, it is have followed by a predicate followed by the argument. So this is sort of a general form. Something like this, if that makes sense. Okay, which we have in this case, our predicate is just integer. And again, if we run this with 5, we are going to get back 25 as expected. If we run this with a string now, we are going to get a detailed error message, which is going to help us actually debug this problem if we run into it during development or in production. Most importantly, I would say we have the value that was input. Okay, so when this condition fails, it's going to tell us that it failed, and it is going to tell us why it failed. Specifically, it is going to tell us what value failed that predicate, that condition. Okay, so we have the actual value, we have the type of the value, we have the namespace, the form that was evaluated, and other things that might be helpful in there. One of the differences that I would like to point out, which isn't super relevant yet, but it will be soon, is the return value of this assertion in Clojure is nil, because the assert macro basically expands into something like this. In other words, when this condition is not true, throw an assertion error. And in the case of Truss, this will return the argument that you provide. Okay, so this is expanding into something different. I'm not going to show the expansion right now, but essentially, when this condition holds true, in other words, when integer of 5 holds true, return 5, return the argument that we're putting in, and that is a useful property for two reasons. Number one, it allows us to use these assertions inline, so you could do something like integer 5. All right. Again, you wouldn't ever do this for a constant argument, but the point is you can have inline assertions because the assertion form is just going to return the input in the event that it passes the check. All right, and it allows us critically to be able to do things like this and have integer n. Okay, again, these are silly examples, but they show the syntax. So the idea here is because this form returns the input argument on successful validation, we can use it in a binding, and we can use that in an arbitrary inline form for our binding, right? So it's just easy to work with. What do we have next? Okay. Yes, one of the differences that I want to show as well, if you have an assertion like this, okay? Divided by n, I would say 2 divided by n. All right, whatever. Again, super synthetic examples here, just to illustrate the point. So we have an assertion, and the assertion that we're making is that 2 divided by n is an integer, okay? Now, one of the problems that we have with this, with Clojure's assert macro, right, is that if we call this function with 4, oh, excuse me, 2 divided by n, okay. So if we call this function with 2, it's going to pass. If we call this function with 0, we are going to get an unhandled arithmetic exception, a divide by 0, because the assert macro is going to take this entire form, evaluate it as one form, and then check that its value is true. Now, the problem is, while evaluating this form, an exception is going to be thrown because we are evaluating 2 divided by 0. Okay? In other words, this example is causing the assertion to not even throw an assertion error message, because before the assertion is even being checked, before the assertion condition is even being checked, we are already throwing an exception. Whereas in the case of what were we doing here? Whereas in the case of a Truss assertion, okay, so I've just rewritten the Clojure assertion as a Truss assertion. Whereas the case with the Truss assertion, if we run this now, and we run 2, again, we get the correct output, and if we run, for some reason, 4, we are still getting a proper assertion error message. In other words, the assertion is still failing. In the case of Clojure's assert, in the case of Clojure's assert, this doesn't trip because of an assertion error. This trips because of a divide by 0, right? Which means that we don't even get an assertion error and the information that that would contain, right? If there's a warning message or something like that. Whereas in the case of Truss, if we do this, this counts as an assertion failure, which means we get the full amount of information, all the usual Truss debug information. In particular, you will notice here we get information about the form that tripped, okay, that failed the assertion. We get the input. In this case, the input is undefined, and that is telling us that we didn't even get to the point where the predicate integer is applied to the input, the 2 divided by 0. In other words, something broke before we even got to that point. In this case, that is also indicated by the value that we get over here. So there was no value to test because something threw an error. We get the attached stack trace for the error that was thrown, and we get a bunch of debug information that is handy for figuring out what actually happened, right? So far we have 2 differences between Clojure's assert and have the Truss version. Okay, this one returns nil, returns input. Okay, and this one doesn't trap errors. This one traps errors. So that is 2 differences that we have so far between those 2. Okay. That make have a little bit more useful, I think. Let's see what else we have here. Okay, destructured binding. So one of the conveniences that we can do, that we have with the assertion, with the Truss assertions, is that if we have something like string hello, That is going to pass, and that is going to return the input, right? But there is also a multi-arity version of the have macro, hello world. Okay, we can keep one predicate, the same predicate, but now instead of providing one argument, we are providing multiple arguments, right? And instead of returning the single string, it's now returning a vector of the input arguments. So where this is useful is, I don't know, I'll do this, x, y, whatever, string x, y, okay? So again, toy example, we've got join, we want to join two things, two strings, or two things that are representable as a string. So we'll say hello, and we will have world over here. Okay, so that's just going to join two things. Let's say that we want to assert that these things are actually strings. In other words, currently if we put in hello 5, it's going to work. It's going to get the string representation of 5. But let's say that we want to enforce that x and y are both strings for some absurd reason. Okay, so in Clojure, we could do an assertion string x, assert string y. Okay, or just for some variety, string x, string y. Okay, so we've got a precondition over here. So let's say that we are doing this now, and we have hello world. That is going to work as expected, and if we put in a 5, it is going to throw our not terribly useful assertion error message. Okay. What you'll notice is doing this with Clojure assertions is starting to get tedious. We have multiple arguments. In this case, both of them we're looking to satisfy the same predicate in both cases. So if we want to keep this a little bit shorter, we could do something like assert every string x, y. Now, aside from that being slow, that also is going to mean that we have an even less useful error message, because now we know that one of the arguments has failed our predicate, our string check. We don't know which one. We don't know what the input was. Okay. If we want to convert this to Truss, we can do something like x, y, have string x, y. Okay. So we're now using the multi-arity version of the have macros, and instead of putting in one argument, just x, we're putting in 2. So that is going to return a vector of the inputs on success, which means that we can easily destructure them in a case like this. Okay, so join hello world is going to produce the output that we're hoping for, and if we put in a broken input somehow, this is now going to give us a useful error message. In particular, okay, it is going to give us the particular value that failed validation. So it's not going to say something failed validation, it's going to say this failed validation. This was the actual value that came in that failed the predicate. What predicate? Well, we have that over here. So string of y failed when y was equal to the integer 5. In fact, it was a java.lang.long if we want to get more specific. So far, so good. So we are slowly improving the error messages in the cases that we care about. And let's see what else we have. Okay, attaching arbitrary debug data. So let us say, I suppose I can pull this example directly from here. Let us say that we have something like this. Okay, we have some sort of a ring handler. A ring request is coming in. So that's a map with a bunch of stuff, a URI and parameters or whatever. We've got 2 other arbitrary parameters coming in. What we want to do here is enforce that the x and y parameters are both integers, which we're doing over here. Okay, but let us say that for whatever reason, okay, something is wrong. So what is wrong in this case? Well, we are passing in x equals to 5, y equals to 0. Because of our check over here, we know that y is supposed to be an integer. We can follow that up over here in our error that we're seeing. The value is coming in on 0. for integer equals y, that is what's stripping, okay? But let us say then in order to properly debug this error, we need more information than just what x is and what y is, because this is a ring request and we want to know, what parameters maybe produce the x and y values, or we want some sort of authentication information, we want the session information, we want something else, right? So one thing which Truss allows us to do as last arguments to the have call, we can include the special keyword data, and whatever follows data is arbitrary debug information. And this is going to get included, where is this going to get included? Over here, okay? In other words, whatever we include over here is going to be included in the error message of any Truss assertion violation, okay? If the invariant fails, we're going to get this information. And that allows us to include information from our environment. So for example, we can say ring request, foo bar, whatever, okay? State from our application, maybe thread local bindings, whatever, parameters to the function, arbitrary expressions, anything that we want. This information can be anything. It can be a string, can be a map, can be a collection, can be a record, whatever you like. And if we run this now, in this case, the data that we're getting is the original ring request as it comes in, and the foo as a bar string. So the whole point behind Truss here is that it is giving us hooks to conveniently attach extra debug information. So this is going to be particularly useful if you've got some sort of hairy logic, you're checking some kind of a condition on the state of your application, someone is clicking a button, and if the application is working correctly, the only way that they should be able to click that button is because they are logged in. You can check the authentication state to make sure that they're actually logged in. In the event of an assertion failure, i.e. they've clicked the button but they're not actually logged in, let's include debug information from their session, let's include debug information from whatever, right? This is your opportunity to include anything else which you might find useful in the event of some sort of validation failure. One easy way of using this is to actually use dynamic data, so thread local or binding data. And one way of doing that with Truss, we use the with dynamic assertion data function, okay? And if I recall correctly, yes. So this argument here is arbitrary data, whatever we want here, okay? And if we call our function with this, okay, you will notice that we now have a star data key, which includes any thread local dynamic information at the time of an invariant violation. Does that make sense? So what you can do, a common way of using this, as I have in the examples, is if you've got some sort of a ring handler, you wrap the ring handler. In other words, you have like a ring middleware, which is going to wrap ring session information or whatever, so that if any invariant, any Truss invariants happen to fail during the processing of the ring request, the ring session information is automatically going to be attached to the debug information, right? So again, I find that particularly useful for things like ring requests, but you may have other uses of that, or you may find it just an easy, convenient way of attaching debug information, like if you're writing a custom validator or something like that. Let's see. All of these are just from the official examples now. So yes. Okay. So what if we have a function like this? Well, let's go back to the original full names example, which we had, which was string join something like this, map string capitalize names. Okay. So let's say that we want to enforce that all of our names over here are actually strings. Okay. So we call full name Stu Ellis. All right. So that is producing an expected output. If we give it a nil, we're going to see the same error that we saw at the beginning. So a null pointer exception, which is not particularly helpful. If we want to assert that all of the names are strings, right? Again, stupid example, but just go with it. If we want to do this with Clojure, the easiest way of doing that would be something like this: every string names, okay? And that is going to produce an error message that is not a whole lot more useful. We know that one of the names has not satisfied string. We don't know which. We don't know what type it was. We don't know what value it was, okay? So how can we convert this example to a Truss assertion? We want to assert that every name is a string. Well, Truss gives us, again, a convenience for doing that. We say have string names. We can't do, because names is not a string. Names is a vector. And in fact, what we want to do is we want to inspect inside the vector. We want to evaluate names as a vector and look that its elements are actually strings. So Truss gives us a way of doing that, which is with the special in keyword. So we say have string in names, okay? And what that's going to do is essentially this kind of thing, where it's going to search each individual member of the collection, and it's going to check that each of the individual members of the collection satisfy the string predicate. Now, why this is nice is because if we get a violation, we get a very clear violation, and we know exactly what member failed and why. So, for example, here, okay, we see that a string check failed, a string predicate failed. Okay, this was the form that was violated. String of some input failed, and the value was nil. The type was nil. Okay, in other words, we have identified the particular member of this vector which has given us problems, which has failed. Okay, does that make sense? Yeah, let's see what else we have in here. Okay, special predicates. All right, so I will just illustrate again that so far I've been using the Truss API for simplicity reasons to do simple type checks. Like, is this thing nil? Is it a vector? Whatever. But the thing is that you are totally free to write an arbitrary predicate here, okay? If we're going to have some sort of a predicate on X, that could be any predicate. It's an arbitrary function, all right? And this doesn't need to be a check against one of the arguments to the function. It could be a check against your application state. What am I doing here? Could be a check against your application state. So state. Okay. So this is now a predicate. Okay, an assertion. It's an arbitrary predicate against the value of our application state when this function runs. Okay, so this predicate over here, okay, is going to receive the input argument. The input argument in this case is some sort of arbitrary application state, and what you check at this point is entirely up to you. You could do whatever you want. You look at authentication information, you look at the state of certain variables and how they're relating to each other. It could be type checks, it could be whatever you find useful to check at this point. So, for example, something that I do a lot of with this is if I'm writing some sort of a client application and the UI has some particular state, like certain things should be visible at the moment, certain things should be available, certain conditions should be met in order for this function to be running, I just check in this predicate over here that those things that I'm assuming are always going to be the case are indeed the case at this point in the execution flow of the program. So that if something breaks, right, some expectation, some assumption that I had breaks while we are refactoring the code or while we are adding some kind of a new feature or whatever, I'm actually going to get an error message that is useful and that it's going to tell me why has this broken, what aspect of the condition, what was its actual value, and basically give me as much debug information as possible to help me figure out the problem the cause of the error as quickly as possible, if that makes sense. We have also, where did I go? We have also some convenience syntax. So if we have something like have string hello world, okay, and we want to say that some argument, let's say in the functioning of our program, okay, so we have this. Okay, so it's taking an x, it's checking that x is a string, and it is appending comma world. So we say foo hello, and we get hello world, and we want to check that the input is actually a string, right? So let us say that it is it should be valid that this input, this argument x, is either a string or it is nil. So that's a common case in Clojure. Very often you're going to be dealing with nils, and you're going to have a lot of conditions where you want something to either have a particular type or meet a particular condition or be nil. Okay, so let's say that we want to get that kind of check over here. So one way of doing it would be string have or string string, what do we have, x world. Okay, so over here what we have, let's put this up so it's a little clearer. Okay, so here is our condition, or here is our assertion anyway, our Truss assertion. This is the predicate, this is the input, and the predicate in this case is the thing that we're getting in the input is either a string or it is nil. So this works because it's just an arbitrary function, right? But that is a little bit verbose for what is essentially a pretty common case. So Truss includes some extra syntax for things like this. You provide a vector as the predicate. You provide or, an or keyword is the first, and then you can do something like this, which essentially says this predicate is now either a string or a nil. Okay, if either of those predicates is satisfied, then we are satisfied. Okay, if we put in a 5, this will fail because it's not either a string or nil. But if we put in a nil, it will pass because it does satisfy the null predicate. Okay, so again, this is an entirely optional bit of convenience syntax. If you want it, you can reach for it. If you don't want it, you don't need to reach for it. If you find it confusing or you forget how it works, just write it out as an arbitrary function, right? And there are a bunch of little convenience predicates like this, or little bits of convenient syntax like this in Truss. So you can do things like and it's a string, or let's say and it's an integer and it's positive, okay, for a number. So if we put in -5, that's going to throw, because it's not both an integer and positive, okay? And we have a bunch of other bits of convenient syntax, so we can do things like, let's pull this out of the context to make it clear. So we can have something like have element of A, B, or C. Okay, so again, this is the predicate, this is the input. Okay, this predicate is a short form element. In other words, the input needs to be an element of this set, and it is. If we put in a D, it's going to fail because it is not an element of that set. Okay, so element set is one of the special predicate forms, just to save you a little bit of time, because writing that as a sort of function can involve some effort. So other common things: keys smaller or equal to A, B, C, A, B, B, C, C. Okay, so what this is saying, this is our special predicate. Okay, this is saying that the keys of our input, which needs to be a map, the keys are a subset smaller or equal than A, B, or C. So this will pass if we include an additional key, D, this will fail, right? Because our keys on this input are not a subset of A, B, and C. They are a superset. And we have keys smaller or equal to, we have keys equal to, we have keys bigger or equal to for a superset, and various other little bits of syntax there to help sort of deal with common case predicates. One of the other sort of commonly used, most commonly used shorthands is if you are doing something like this, not nil. Let's say you have an argument. Okay, so we want to check that x is not nil. Okay, we can write something like this. Have not nil is our predicate of x. Okay, or if you are using a newer version of Clojure, you can do something like that, which is the same thing, some function. So this is a common enough case in Truss. In other words, you're going to want to check that something is non-nil often enough that there is a shorthand in Truss, which is just don't provide any predicate at all. If there is no predicate, in other words, just have x, that expands to have some x. Does that make sense? So you can use that as a way of checking. Foo, hello, will pass. 5 will pass. Collection will pass. False will pass. Nil will fail. Because the check was that x is non-nil, but this x was nil. Okay. Other things that might be useful. So I've given an example here in the examples. You can, of course, use a custom predicate. If you have, let's say, a little function here that you define as a positive integer, have pos int 5, right? Because this is just a function. Any old Clojure function could be an inline function, could be a function that you define somewhere, which means in particular that this could also be some sort of a validator that you have written for your application. Okay, so let's say we're dealing with some sort of a map, which we're calling a person, and we want to define sort of characteristics of that that map, which are important to that thing being a map. So in this example here, we say, well, person is a map. First, check that it's a map. Then check that it has at least the age and name keys, and check that its age is either positive integer or nil. Okay. So if we run this person, let's say we run this against nil, it's going to throw, and we know that it's going to throw because nil does not satisfy the map predicate, right? So that's throwing right away because over here, map of person was our condition, and the value that we gave was nil for person. So clearly that's going to fail. If we give it an empty map, it's still going to fail. Why is it going to fail now? Because the condition, keys being a superset of age and name, was not the case for this map with no keys. Let's say we put in age, age 20, name Stu. That is still going to fail. Why is it going to fail now? Well, because age of person did not satisfy the predicate either nil or positive integer. In other words, we can either make this nil and it will pass, or we can make this an integer, positive integer, and it will pass. Now, just to satisfy, if you have a negative integer, it will fail because the predicate or nil positive integer was not satisfied with the value negative 20. Okay, so the point of all of this is just to have a way of expressing inline any kind of condition. Any kind of condition of the form input. This needs to return truthy if the condition holds true, and then the actual input. That's it. and this will return input if true. So that's the basic syntax form, and the whole idea here is that this you can place anywhere you like. You can place it in a binding, you can place it inline, you can check types, you can check state conditions, you can check whatever you like, and you have a bunch of conveniences for improving the error messages, like you can provide arbitrary data, you can do multiple checks simultaneously, or I mean linearly, but with one form for convenience. You can use syntax, special syntax for the predicates in order to do common case things, like join certain predicates as an or an and condition, that sort of thing. And you can do, of course, you can use the in order to check within a larger data structure. Okay, so it's just an API to help you improve or get very, very clear error messages on annotated forms. And that is it. That's the Truss API. I will quickly explain the difference between this is that it well, the difference between this and this returns the input on success, and this returns a truthy value on success. All right. Most of the time, you're not going to care about this form unless you are writing pre-post conditions and using Truss in pre-post conditions, which I would normally recommend against anyway. So if you have something like foo x pre have string, well, let's do it this way, or nil string x. All right, so this is another silly function that just returns the given argument, but we're checking whether the given argument is either nil or a string. Okay, so we run this with hello, and we get back hello. We run this with nil, and we get back nil. Now, here, in this case, it is important to use the have question mark form of the Truss API, because if we run this on nil, what are we expecting the output to be? If this succeeds, right, it's going to return nil. But nil is not truthy, which means the precondition is going to fail. So if we have over there, and we run nil over here, this is going to fail. And you will notice it's failing the Clojure assertion, not the Truss assertion. In other words, the precondition that is supposed to return a truthy value is failing. So we get no good error message because it's actually Clojure's assertion and not Truss's assertion that is being tripped. So this is an edge case. You don't need to worry about it most of the time. But essentially, if for whatever reason you've decided to use Truss assertions in pre or post conditions, just make sure you're using the variant which has a question mark, because that will return a truthy value instead of the given argument or arguments, if that makes sense. The other point, or the other API variation which I want to point out quickly, is this one. Okay, so this is have bang. The only difference between have bang and have without the bang is that this one can be elided in production. This one cannot. All right, so the Truss have assertion, like the Clojure assertion, pays attention to the value of Clojure.core/assert. In other words, if you compile your Clojure project and assert happens to be false, then all of your Clojure forms of the form all of your Clojure assertions are going to get elided. They're going to be eliminated from your code base entirely. Now, in the case of Truss assertions, if you have something like this, okay, because the Truss assertion actually returns a value, okay, it returns the input, Truss assertions are elided in such a way that they just pass through their value. In other words, if assert is false, then this bit of code is exactly equal to just foo. Okay? But the ability to support elision in production is useful if the check is just for something that you would like to catch for debugging, or it's something that you think might break, and if it does break, you would like to get a nice clear error message. It would not be suitable to support elision on something which is an important security check, let's say. So if you're checking something that is a like an authentication check, that you're asserting that a user is logged in or something like that, you are probably going to want to use this form with the bang. And essentially the implication there is this is an important assertion, never elide it. Don't ever allow it to be skipped. All right? So that the bang does two things. Number one, it conveys the meaning that this is an important assertion that you don't ever want to have skipped. And number two, it actually prevents the elision in case you happen to be using Clojure's assert value to control things like that. So that is it. Let me think, is there anything else to point out? That is it. These, again, have all been examples of syntax, basically, not so much use case. The places that I would consider using Truss assertions are in the hairier bits of a complex code base where you've got some kind of function, it's calling out to other functions, there's data coming in, maybe it's coming in from the user, it's coming in from multiple data sources, and as you were working with that data, you have certain things in mind that you were assuming about your environment, about your application state, about the types that you were dealing with. Instead of just assuming those things and believing that they are going to be apparent from looking at the code, or from the context, or for something that you know about how the application works, you have the opportunity now with Truss to actually formally annotate your code, to formally include in your code these assertions and say, all right, look, at this point in the application, I assert officially, formally, that the user is logged in. If the user is not logged in, then something is wrong. Something has gone wrong. Either there is some sort of a security problem, or there is a bug, or whatever. Give me the most detailed information you possibly can. Right? So those assertions work both as a form of documentation for someone reading the code, because it helps them understand what kinds of things are we taking for granted at this point in the code. For example, we're taking these conditions about the application state for granted, and what type assumptions are we making at this point. So maybe we're working on something, some kind of a collection. We are enforcing that it is a vector because we want to have we want to use vector operations on this thing, and we're sort of depending for performance reasons on the performance characteristics of a vector compared to sort of an arbitrary sequence. So we can now say something like v vector my collection. At this point in the code base, we have clearly identified that moving forward, this thing we are assuming is actually, in fact, a vector. It will always be a vector, which means when we are banging on it later on over here, we should feel free to use peek, we should feel free to use pop, we should feel free to use subvec, because we have at this point made the assertion officially, formally. This thing going forward is a vector. If it ever at any point in development or production turns out to not be a vector, something has gone wrong, right? So that forms that acts again as a form of documentation and as a form of protection in case something does end up going wrong. We feel confident that we are going to get a very clear error message with as much debug information as possible to help us solve the problem as quickly as possible. And that is it from me on the examples. Thank you for watching. If this video thing turns out to be a popular format, I might try to get into the habit of doing more of these for stuff that I put out, so let me know. Otherwise, you can find links to Truss, including documentation, and my other stuff at www.taoussanis.com. I also have my contact details there, so please feel free to ping me on Twitter or email if you've got any questions or want to say hi. And that is it. Hope there was something useful in here. Either way, Happy New Year and happy hacking.